Hey everyone, it's Matt here with Nightrun Studio, and in this mini-series we're doing a deep dive into enemy AI. This first video is going to be a little slower paced because we're laying the foundation for everything that comes next. The goal here is reuse. By the end of this video we'll have a simple patrol state that can detect cliffs and walls, and while this may not look flashy, it's the backbone of every enemy we build from here on. At the center of the system is an enemy core script. This is our quarterback. It holds shared references, handles logic that multiple states need, and deals with anything it has to interact with the physical world, like flipping the character when it turns around. On top of that, we'll have a lightweight state machine that handles the repetitive work that happens every time we switch states, so we don't have to rewrite the logic over and over again. We'll have a base state, a template that defines the structure every state will follow. Things like enter, exit, and update live here. Each actual state then gets its own class, which lets us focus on what the enemy does in that state while keeping our scripts small, readable, and easy to debug. Now, while states decide what the enemy does, we'll also build a parallel system of core components that define how those things are done. For example, a state might decide that the enemy needs to turn around if there's a cliff ahead, but our enemy senses component does the actual detection. That way, any state that needs that information can just ask senses and we avoid duplicating logic. Finally, we'll set up an EnemyConfig script. This holds all the enemy stats and tuning values and lets us define different enemy types using the same code. Give an enemy 0 ranged detection and it simply won't behave like a ranged enemy. Alright, that's enough setup, let's get started. Now, while this video is designed as part of our Metroidvania series, it should also work as a standalone, so if you're just joining us now, don't worry, I'll try to point out anytime there's any background information you need. So, first of all, in your scene you will need to have a character, and you're going to need some sort of a tile map for your enemy to move around in. With that done, let's actually get an enemy in here. For this series, I'm going to be using Matt's Art's Kobold Warrior 2D. You can download this one for free, and it is free for commercial use. I recommend that you give this some love and maybe even take the time to rate it to help the artist out. Alright, once this one is downloaded, you'll need to head to your downloads folder, unzip the file, and then drag and drop it into our sprites folder in the project. Inside the project then, we can open that up, and we're going to go ahead and grab the characters. I'm using the ones without outline so they match the rest of our art. Here we've got 3 different states, and they each have their own animations already sliced up. I'm going to go ahead and just drag in the attack number 1 here. That said, we're going to need to do a little bit of work with these sprites quickly before things will look right, as that's a problem. So let's shift click all of them so we can do them at once. I'm going to make this one 16 pixels per unit. That way its pixel size matches all of the other assets in our scene. We'll change the filter mode to point no filter to get rid of that blurriness. And then we'll also set the format to the higher quality 32-bit, which will just clean up our colors and make things look about right. Next up, we'll just click on the character, and I'm going to set his order and layer a little higher so that he renders in front of our ground layer. And I'm also going to rename him as a kobold. In my scene view then, I'm just going to quickly grab my move tool and drag him into place. Let's give him some physics next, so we can add a rigid body to give him gravity. And here in our constraints, let's make sure to freeze his Z rotation so that he doesn't topple over when he bumps into things. We'll also make sure to give him a collider. I like the capsule collider as it doesn't have any rough edges that can get caught on corners. I'm just going to size this one in a little bit so that it matches where the core of his body is and he doesn't end up getting stuck on his tail or ears. Now, if you've been following along with the rest of the series, when you get to our scripts folder, you'll see that we already have a script called enemy. We'll reuse that code later, however, enemy isn't a great title for this. We're going to rename it to enemy damage. Then I'm just going to right click, create a new folder for all of our enemy scripts, and we'll drag it in there. With that done, we are now ready to actually get writing some code. Let's create our first script called enemy. Now first off, let's get rid of our start and update methods so we have a clean slate here. Now enemy is going to hold shared references that our states need to access, so let's make a public rigid body 2D reference. We'll call this one RB. And we're going to actually make this one a property, which is why I'm capitalizing the first letter. This allows us to control how other scripts access and read this, and it also makes it so the reference does not appear in the inspector, which allows our inspector to stay clean. Now because it's not in the inspector, we're going to actually find it in our awake method. So as soon as the game wakes up, we're going to tell it that our rigid body is equal to, and here we'll just get component rigid body 2D, as it's going to be on the enemy itself. Our update method is going to be super simple. Since our states won't be mono behaviors, they won't have access to things like update. And so in update, we're going to tell our state machine that it needs to update whatever state we are currently in. I'm also going to get rid of these brackets. We can do this if we like anytime a method only has one function that it runs, as it just keeps our code looking nice and clean. I'm also going to put a question mark here. Next up, we'll just make our fixed update method and do the exact same treatment for it. Now, if we go back into Unity, we're going to get a couple of errors that are just telling us we're trying to talk to a state machine that doesn't exist yet. So our logical step is to go ahead and create a state machine script. Now, our state machine is a super lightweight script that just determines how we switch between our different states. So we're going to get rid of mono behavior, as state machine won't actually live inside of our scene, it's just helper logic. At this point, we are going to need to keep track of what our current state is. So we'll make a public state called current state, and we'll also make this one into a property so that we can control how it's accessed. We'll then need an initialize, which is just where we actually feed it information that it's going to need to make our states work properly. Like, for example, the state we're going to start in. As soon as the game begins, our enemy script will call this method and pass along the state that it wants us to start in. It'll also tell our current state that it needs to run its enter method. That's the only logic we need for now, so we'll pop back into Unity where we're getting an error because now we're trying to talk to a base state script which doesn't exist. So let's create that script now. Now, as a reminder, the state is sort of a template for all of our different states that defines the different methods they will all have access to. So let's go ahead and get rid of start and update, and this one will also not be a mono behavior. It's actually going to be an abstract class. We'll do this by creating virtual void methods. We'll want to make sure that we have logic for when we enter a state, as well as for update and fixed update. Again, we're doing this because our states are non-mono behaviors, and so they don't have access to these lifetime methods unless they get passed into them from our enemy. We'll also make sure that we have some logic to run when we exit our state. All right, now that we've created our state, we can get rid of those state errors, but we've got some new ones now, and that's because our enemy script is trying to give commands to our state machine, which, while it exists, there's not yet a reference to it. So at the top here, we'll make a state machine reference, making this one a property as well, as we don't need to see it in the inspector. In our awake method, rather than find this script, since it doesn't exist in our scene as a mono behavior, we're actually just going to create it. And with that done, we'll now have access to all of the state machine's logic. Back in Unity, we're finally error-free, so let's go ahead and put our enemy script onto our kobold. He now has access to all of the logic we've written so far, except that we haven't actually told him to do anything yet, so it's time to create our patrol script. Okay, let's clean this up by getting rid of our start and update methods. And remember, this isn't a mono behavior, instead it's inheriting from that state script we wrote. Now at the top, we're going to create a constructor. In this case, the script is going to need to know about our enemy script, so we'll pass that in. And then we'll also tell it to pass that enemy reference along to the base state. Now we can create our methods. We're going to have an override method for fixed update. My code is automatically filling in base fixed update, but there's no logic in our base state's fixed update, so we can safely get rid of that. Now the first thing we want our patrol state to do is to actually move our kobold. So let's get our rigid body and set its linear velocity to a new vector. We don't yet have any speed variables, so let's just hard code it at 5 for now, and we'll fix that later. And we don't want to do anything on the y-axis, so we'll just let our rigid body use its own velocity on the y. Now, we would get errors if we popped back into Unity because our patrol state doesn't yet have access to the rigid body, so let's head over to enemy and make sure that we pass this along. So at the very start of the game, once we've set up our state machine in awake, we can now tell the state machine to initialize itself. At that time, we're going to pass along what our starting state is, which is going to be a new patrol state. Now, if we went into Unity now, errors would abound, and the main reason is because we're now calling our state's constructor, but we're not passing along the information it expects, which is a reference to our enemy script. So when we construct the state, we just want to make sure that we pass this, which is a reference to the script we're in. Now the patrol state itself will have access to all of the variables and logic inside of enemy. And so we could just type enemy.rb.linearVelocity here. However, it's going to be annoying putting the enemy prefix in front of RB all the time. So let's pop over to our state script, where first of all, we're going to give it its own constructor, so that anytime we construct the base state, it also takes in a reference to our enemy. Now we'll give it that public rigid body reference called RB so that it's cached and our states can access it easily. And then, as soon as we construct our state, it's just going to know that the rigid body is equal to the enemy's rigid body. That'll clear up any errors in our patrol state, which can now just talk to the RB by saying RB. I know that was a lot of setup, but we're finally getting somewhere now, and when we hit play, we should be able to watch our enemy move at a speed of 5 and go off the cliff and get stuck against a wall. It's a mess, but it's working. Now there's a couple of obvious problems here, like going off the cliff, but the first thing we're going to fix is giving us the ability to control our enemy's speed. So at this time we can create our EnemyConfig script. Now EnemyConfig is just going to be a big data container that holds all of our enemies' different stats, and so it won't inherit from MonoBehavior. It's going to be a scriptable object, and we'll just create one of these scriptable objects anytime we want to add a new enemy to our game. So let's begin with a header for movement, and here we'll just hold our patrol speed value. Let's default it to 5, though we can change that later. We'll then make another header that'll hold our patrol specific data. Here we'll just hold our configuration values. A float for our ground check distance. We'll have a layer mask for what he determines is the ground layer, so different enemies could actually walk on different surfaces if we want. At this point, we need a way to actually create these scriptable objects in-game, so we're going to create an asset menu with the menu name of enemy and a specific name of EnemyConfig. Now we can create data for our first official enemy by creating an enemy, EnemyConfig. We'll call this one Kobold, and then on the side here we can just give it some data. For the moment that just means selecting a ground layer. If you're just joining us for this video and don't have a ground layer yet, you can get that by clicking on whatever your ground object is, and then up at the top right you're going to want to pick layer and add a new layer. So how does this config work? Well, if we were to go into our state now, we can replace that hard-coded 5 value with a reference to our config's speed. Now, just as with our rigid body, we will need to set up that reference to EnemyConfig. So let's head to our state where we can make a protected EnemyConfig variable. We'll call it config. Then, when we construct this state, we'll make sure to cache that variable that we'll get from our enemy. That said, enemy isn't yet aware of this, so we'll then head over to enemy, make sure that it has its own variable to hold the EnemyConfig. This one will not be a property, as we'll need to see it in the inspector so we can drop our scriptable object into the slot. That should make us error-free when we go back to Unity, and now for our enemy we can drag his Kobold scriptable object into the enemy script. I'm just going to move him back and set him in place, get the player out of his way. And now when we hit play, we can actually adjust his speed in the scriptable object, and we will adjust the actual speed of our character. All right, we're starting to get somewhere. Next, we just need to make sure that he doesn't keep running off that cliff. To do that, our enemy needs a way to sense the world around him, so let's create an enemy senses script. Inside of this, we can get rid of start and update. And then before we get writing any logic, we just need a couple of references. The first will be serialized, EnemyConfig reference. We're also going to have a transform reference to our ground check. Now we can create our first piece of logic. This one's going to be a public bool method, as it's going to return a true or false value, and we'll just call it isAtCliff. If there's a cliff, it'll return true, and if not, it will be false. Here we're just going to use a physics 2D raycast, so we'll shoot an invisible line downwards. It's going to originate at the position of our ground check. It will always go downward, and then here we're going to use our config's ground check distance to know how long a line to draw. What's it looking for? Well, it's looking for something on the ground layer, which also comes from our config. Now, as this is written, we would actually return that yes, we're at a cliff when there's actually ground under us. So we need to negate that. We'll do this by putting an exclamation mark in front. And then, while we could leave this as written, I want to make it a little more compact, like we've done with some of our other methods. So let's get rid of the curly brackets and add in the lambda expression. All right, now let's quickly do our wall check. We're gonna duplicate this transform reference here, but rename it to wall check. And then we can actually copy our isAtCliff logic as well. We'll give this a nice common sense name like isHittingWall. Make sure that it's looking from the wall check position. We're going to use our config's wall check distance, and finally look for a wall layer. Now we're gonna need to add those values to our config, but first let's just make sure that these vectors are vector2 so we don't get errors. And then for our isHittingWall, we want to remove the exclamation mark, as if we're hitting a wall, we want to return a true value, not the other way around. Now we can just pop into EnemyConfig and add those wall check variables. We'll duplicate our float for ground check distance and just change it to wall check distance. This one can also be a little smaller. And then let's copy our layer mask and make a wall layer. Now that we've got our senses set up, we actually want to use them. So let's head into our patrol state, and in fixed update, rather than moving all the time, let's do an if check. So if our enemy senses say that we are hitting a wall, and here I'm going to pause as we don't have a reference to enemy senses and we need to set that up. Just like with our other variables, let's cache this once so that we don't have to redo this every single time, and we'll make sure that in our constructor we assign it. We'll then head to enemy, make sure that it actually has a reference to enemy senses. Again, we'll make this one a property, and then we'll just make sure that when the game wakes up, it finds senses by looking on this game object and getting that component. Now our patrol state can easily access the enemy senses by just typing senses. Now we want to check if we're hitting a wall here, but we also want to check, so we use the or statement, if our senses say we're at a cliff. If either of these things is happening, that means that our enemy needs to flip around rather than move. Now we don't have flip logic yet, but let's put return, and then for testing purposes, let's just print a debug log here when he finds a cliff or wall. Back in Unity, we've got some setup to do, so let's click our kobold and add the enemy senses component. We can start by dragging in our kobold's config into that box, and now we need to make a ground and wall check. So I'll add an empty object, which we can call ground check. I'll then just duplicate that and call the next one wall check. We can drag each of these into their respective boxes, and then we just want to make sure that they're in the right location. So for example, let's grab our ground check and put it down by our feet, and then we'll grab wall check and put it out in front of him so that it's looking for a wall at the front of the character. Now before I have a chance to forget, I'm just going to click on my kobold's config and make sure that he knows what the wall layer is. Now when we get in the game, I'll follow this guy along, and sure enough, our I found a cliff debug is printing. Admittedly, that's a little underwhelming. So let's pop into our enemy script, and actually I'm just going to make a little note here that those are components down below, and now we'll make another note for actual variables. And here we're going to make a public integer that's going to track our facing direction. This one's also going to be a property, and we're actually going to set it with a default value of 1. I'll just pop into Unity quickly to show you what we're going to be doing here. And so with our kobold, if we look at his transform, we're just going to change this scale x value so that when it's 1, he faces right, but if we switch it to a -1, it turns him around to the left. All right, let's actually create the logic now. So we'll come down below here and make a public flip method. And here what we want to just do is change our facing direction by multiplying it by -1. So that'll just flip its value. At this point, it would be great if we could just tell our scale that its x value needs to change, but Unity won't let us do that. So instead, we're going to store our current scale in this scale variable. That'll just get our transform's current local scale. Then we can take that variable and change its x value to whatever our facing direction is. Now our stored scale value is what we want our actual values to be, so we can tell our transform that its local scale now needs to take on the values we've stored in scale. Now if we go to our patrol state, we can head into our if statement here and just tell it that we want it to flip whenever we hit a wall or cliff. That said, flip is in our enemy, and our state doesn't yet know how to find enemy. And so, just as we've done with everything else, we're gonna have to cache that value. The beautiful thing is that once we've done this for our first state, we won't have to anymore for any of our other states. Now, since this enemy and the one that's getting passed in use the same name, we'll add the keyword this to determine which one is which. Now in patrol state, we'll just make that a lowercase e so it matches, and then when we set our velocity, we want to make sure that we always multiply the x value by our enemy's facing direction. Now when we get into Unity and hit play, our enemy is in fact flipping when he gets to cliffs. If I jump over his head, he'll flip when he gets to the wall, but the jumping over his head is annoying. We want to make sure that he's not bumping into the player like that. To do this, let's click on our kobold and make sure that he is part of the enemy layer. And then let's click on our player and make sure that he is part of the player layer. At this point, we can go to Edit, Project Settings, and we want to go to our Physics 2D. Here we can go to the Layer Collision Matrix and just make sure that our enemy and player layers don't detect each other. Now when we get in the game, our enemy will be able to patrol back and forth without bumping annoyingly into our player. Now we could leave this here. There's one last thing that I want to set up that's just going to make our life so much easier throughout this series. And that is creating some gizmos so that we can visually see what our enemy's detecting instead of always guessing where to put our checks and how big to make them. Alright, in our enemy senses, let's pop down to the bottom and create a new void method called onDrawGizmos. This will run anytime we are in the scene view, which actually could be problematic as we don't want all of our enemies to be drawing gizmos all the time. So let's use onDrawGizmos selected. That way it will only draw these gizmos when we're actually clicked on this enemy specifically. So for the first one, let's start by setting its color. I'm going to go ahead and make this one yellow. And this works a lot like a raycast. We'll just tell our gizmos to draw a line starting at our ground check position. And it's going to go from our ground check, and we're just going to add a downward line that we're going to multiply by our config's ground check distance. I'll just put a note that this is our ground check. We'll then copy all of this, paste it in, and make our wall check. Let's give this one a color of blue, and then change our ground check to a wall check. This time the line's going to go from our wall check's position, and we want to go to the right rather than downward as we're looking for a wall. We'll also make sure that we're using our wall check distance. Now, unlike the ground check, this one is going to need to go in a different direction depending on which way we're facing, and so we're also going to have to multiply this by our enemy's facing direction. Enemy Senses doesn't yet know about the enemy, so we're going to add a serialized reference to it up at the top. And then I'm noticing that I was having some trouble typing. Down below we should be multiplying this by config's wall check distance, not adding a comma. And I'm also noticing that I did a ground check rather than ground check position. Sorry about that, that should work now. Now when we get into Unity, as long as your gizmos are toggled on, you should be able to see lines representing where he's looking for a wall and the ground. When we hit play, we can see that things are working, he's flipping, he's detecting, and we can toggle our gizmos if we want to actually see what's happening. Alright, I know this was a huge one. I promise the others aren't going to be this crazy, but we've got a terrific foundation set up now for our other states. In our next video, we're going to set up our second state, and we're also going to make this look a little nicer by setting the groundwork for how we're going to do our animating. Hope to see you in that video. Until then, this is Matt with Nightrun Studio. Cheers.